All right, we're going to take a look at equations of circles today. It's going to be really exciting. We'll get through two different forms of equations of circles. There's standard form and there's general form. We're going to have to convert to and fro, so we'll get all that completed today. So let's jump right in and get right to it. Here's the document I have pulled up that we're going to go through. First of all, what is a circle? What's the definition of a circle? I imagine we could define it many different ways, but it's a set, let's write it this way, a set of points equidistant from a given point. And we're going to call that given point the center, of course. So if we have a center here, and what do I mean by equidistant? Equidistant means the same distance away from that. So maybe over here, or maybe up here, or over here, or over here, and so on. You see how it's sort of forming this circular shape. If I did that a bazillion times, I would get a bazillion little pixels on my iPad here, and you would see a nice continuous circle that goes all the way around. So that's one definition of a circle. Now, how do we graph a circle like in Desmos? What do we type in? Equation of a circle. There's a couple different forms. We're going to go through standard form first. I should have had that typed in there, but this is going to be the standard form of an equation of a circle. And here's how that works. Given the center, HK, that has an x coordinate and a y coordinate, of course, and then the radius r, we can plug into the following formula. Now the formula has x here and y here, and the formula has a minus in it. Right? And then you put the h. So I'm going to color code this to maybe help you out. So we're going to put, well, actually I wanted red. There we go. Put the h there. And the k is the y coordinate, so it makes sense that it would go over here with the y. And then on the right side, don't forget, well, you haven't learned it yet, so I guess there's nothing to forget, but we're going to put r squared over here. So don't forget that square is what I was starting to say. I'm going to highlight that. Notice these two quantities are also squared. So it's x minus h squared plus y minus k squared equals r squared. So don't forget that square. So here we have a given equation. We can harvest out the information as well. There is a trick here that something we need to be careful about. So this is really x minus something. So what would the something be? It would be negative 2. So h is negative 2 here. You have to change the sign on what you're looking at. So just change the sign on what you're looking at and you'll be fine. The k would be, this is y minus positive 1. So the k is 1 or positive 1. So you just change the sign on what you're looking at. We saw y minus 1, we write positive 1. And then r is what? Well, r squared is 9. So what would r be? You have to square root it. And you get r equals 3. So let's quickly draw that. Negative 2, 1 is right here. And then we go equidistant away, right? That's what the radius is how far to go away. So boom, 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 boom. There we go. I got 4 dots. And then I'm going to draw a circle and watch what happens. Ooh, pretty cool, huh? So we get a nice circle there. There's my circle centered at negative 2, 1. How do we find equations? We plug in. All right, we just harvested the information out so that we could get that graph. We're going to now plug in. So let's write down our standard form here. X minus squared plus y minus squared equals r squared. So I'm going to plug the 2 in here. Remember, we changed the sign, so it was positive 2, so that's why I now see x minus 2. And then over here, we're going to put a 3 for the y coordinate. Now, I was working with some students today on their assignment, and they were writing 4 there. What's wrong with that? What's wrong with writing 4 there? We're supposed to write r squared, and if r equals 4, then we have to write 16 there, 16. All right, and so hopefully that seems pretty easy. That's not so bad. This one has a little trick to it. We have a center here, and we have a point over here. And we know the circle goes through that point. So I can't exactly just count. You know, I can't really just figure out the radius by counting. So sometimes we have to use the distance formula. So the distance would be, this is where you subtract the x's and square. You subtract the y's and square. And by the way, I have another video on the midpoint and distance formula, so I'll try to remember to link to that down below in case you need help on that. So this would be the square root of 3 squared. Remember, sign doesn't matter here because we're going to square it anyway. So this is the square root of 9 plus 1 squared. So that's radical 10. So the radius is radical 10. Now remember, when we write the equation, we're going to be writing r squared, so we actually didn't even need to write all those square roots because we're going to be writing 10. So it is x plus 1, the quantity squared, plus y minus 3, the quantity squared, equals, and this is where we put the 10. Let's see if I could squeeze that in. A little bit off the screen, so let me move it over there for you. There you go. Remember, these numbers, they just came from the center, just like we did a moment ago. All right, let's keep powering along here. We're going to graph. The one from right up here. Right, so 2, 3. And the radius was 4. So we go in all directions here, just like this. And we get our graph there. Okay? All right, let's move to the second page of these notes because it gets a little bit more interesting in the second form of an equation, which is called general form. General form is going to have equals 0 this time. And I like to write it this way: x squared plus y squared plus ax plus by plus c. Some teachers might have like A, B, C, D, E, but I'm not sure we want to do that because it just makes our life easier for completing the square that we're going to do here in a moment. So just trust me on this. Let's use this form for our general equation. Let's always have a 1 here and here just to make our lives a little bit easier. So how on earth do we take a standard form and convert to general form? Well, remember, this is a FOIL question where you have a binomial, you're squaring it, so you always get a middle term when you square it. Let me write that out in case you've forgotten that. If you remember all this and you feel insulted, I'm sorry, but I just want to make sure everyone's on board. So x plus 2 times x plus 2. We then FOIL it out, first outside, inside, last, or if you want to use the box method, that's fine. But at this stage of math, you should be able to do all this in your head. You get x squared plus 4x plus 4. So you do get a middle term when you square a binomial. It's not very often we get to use the word always in math, and you always get a middle term when you square a binomial. The second half of this, if we FOIL this out, we're going to get y squared minus 8y plus 16 equals 64. Now we just need to shuffle things around and get them into this form. We might have to combine like terms, as you'll see here in a moment, but it's really not too bad. So x squared, there I've used that, plus y squared, okay, I've used that, plus 4x, I've used that, minus 8y, okay, I've used that. Now I have 3 things floating around, and notice that the 64 is on the right side of the equation. So I am going to subtract 64 on both sides. And then I'm going to, for you, highlight the 3 different things that we have to add up or combine. So that would be 20 minus 64, which is negative, oops, go back to my pen, minus 44 equals 0, and there we have it. We have just converted to that form. Not too bad, right? What about the other direction? We have to remember how to factor or complete the square, in order to do that. So it says rewrite the following circle that's in general form, and we're going to rewrite it in standard form. So our goal here is, in the end, we're going to have x minus h, the quantity squared, plus y minus k, the quantity squared, equals r squared. That's our goal. Let's figure out how to do this. Well, this is how I like to teach completing the square. I say put all the x's together, leave a little space right there. Oops, sorry. Plus y squared plus 6y, and leave a little space right here. And I'm going to move that 12 just out of the way. I'm going to move it to the other side, so it's now over there. Then we're going to complete the square like this. Some teachers teach how to find that number first. I don't care for that. I think it's a little confusing for students. It's a couple different steps. Let's just do them like this. Let's just divide this number by 2. And then you come back up here and you square whatever you put there. So that means I put a 4 there. All right, so let me repeat what I did. Is I saw this number, I divided it by 2, I wrote it here. And then after that, whatever I put here, which was 2 or negative 2, I square it. You will always be putting a positive number here when you're, squaring something. Now, your spidey sense, your mathematical spidey sense ought to be going off that we just put 4 on the left side of an equation. We're not allowed to do that unless we do what? We balance it with a 4 on the right side as well. So I have to put a plus 4 over there. All right, let's complete the square on the second half. This would be a 3 when you divide by 2. So then what goes up here? It's not 6. 3 squared is 9. And whatever you do to both, you have to do to both sides. So we now have x minus 2, the quantity squared, plus y plus 3, the quantity squared, equals 25. So therefore, I now know the center is at 2, negative 3. I can harvest out that h and k like I did earlier. And the radius is what? Not 25. It is 5. Okay, so we got that, and we also wrote the equation. So look at us go. All right. What about this one here? This one's a little different because I have numbers in the front of x and y, and I know you're thinking, well, you just said you couldn't do that. I didn't say you couldn't be given it, all right, but we might want to get rid of them first, and the way you get rid of them is real simple. You just, it keeps moving around on me here, divide by 3, divide by 3, divide by 3, x squared plus y squared minus 4x. We're going to move that to the other side here in a moment. I'll go ahead and just write it like that for now. X squared minus 4x, we'll leave a little space, plus y squared. It has no friends, sadly, right? The y is all by itself. That's okay. Just introvert maybe. Minus 4/3 goes to the other side. I then complete the square, x minus 2, which means I have to put a 4 up here because 2 squared is 4, which means I have to put a 4 on the other side as well. Now this, you need common denominators in order to add fractions. So just as a reminder, this would be 12/3, which is 8/3 when you add them. So this equals 8/3. So there you go. The question says find the length of the diameter. Well, the radius is the square root of 8/3. So remember the diameter is 2 radii. So the diameter would be 2 times the square root of 8/3. So you could put that in your calculator, or if you remember how to simplify radicals, it does simplify a bit. I'm not going to take time to do that right here. All right, and then I've got one more question that I ask my students to do in the class on their own, but let's just go ahead and do this. You can pause the video. There you go. Pause the video, give this a try. Ready? 3, 2, 1, pause. Okay, now I'm going to go over it. X squared minus 8x, we'll leave a little space. Plus y squared plus 6y, we'll leave a little space. We move that 14 to the other side. See, to me, the way I'm doing this is just a mindless process, and I don't have to really stress about thinking about too much here. I just do these steps. And generally, I think students like that when you don't have to think too much, right? All right, this would be a 16 here, which means I got to put a 16 over there. All right, and this would be x plus 3. So I have to put, I have plus 9 here, plus 9 here. So I ended up getting 39 on the right side. So the center is at 4, -3. And the radius would be radical 39. Radical 39. All right, well, I certainly hope that you found this video useful, and if you did, don't forget to like and subscribe. Not only this video, but subscribe to the channel. Really appreciate it, and hopefully, there's the bell. So it is time to go. It's time to close out this video, and again, I hope this was really helpful, and check out the other videos on my channel. All right, friends, until next time.